Hello everyone, and this is Hossein Mokhtarzadeh, and I would like to talk about OpenColab project or OpenSim in Google Colab. Please follow me. So let's keep this question in mind, and then we'll go ahead and try to address this to our 1 minute setup on the web. So imagine a Collaboratory emails you a model, a musculoskeletal model, for instance, based on OpenSim, and he or she wants you to check and run the codes. You're out of office and you only have access to the internet and your Gmail account and no relevant software. Even if you have relevant software, it's not really easy to basically load everything, right? So can you run simulations on your PC when you just have the codes and they tell you that it works on their system, but is everything going to work on your system? So just think about this question. So this is the project OpenSim in Google Colab to explore biomechanics on the web. You can think of Google Docs versus Microsoft Office. So you have it on PC and you have it on the cloud. You can think a little bit like that. So please cite our work here. What is OpenSim? If you're not familiar with OpenSim, it's amazing software, open biomechanical tool in that you can do all sort of forward and inverse dynamic solutions based on C++, and it's got Python, MATLAB, other bindings as well. So it can be used in a variety of things. Thousands of people are using them. It's amazing software. Myself, I've been using it more than 10 years, 2009, I guess, since I started my PhD. It has a lot of application API, so the developers have done a great job. Like API is interface. So method, for example, you write in one language and then you want to see it in another language, or you want to use the functionalities in other languages. So that's the API connection between computer or between computer programs. All right. So see, and then you want to see it in Python as well. So we have Python, MATLAB, Java, APIs for OpenSim. As you can see here, GUI, command line, XML, and so on. Okay, but they're all based on your system. So you install them on system and then you use them, right? So the aim here is in this paper or in this working project that we are pursuing is a cloud-based musculoskeletal model interface. So we're not replacing any of those great APIs. What we're doing is extending it to a cloud-based. And so how to access all musculoskeletal modeling functionalities with zero configuration on your PC. That's the aim, basically. So it's cross-platform. So you're a Mac user, your Windows user, you can actually use them easily, sharing and collaborating, all on the web. We think this is going to be achievable. It's very OpenColab, OpenSim in Google Colab. So I'll tell you, now about OpenSim, so you'll learn more about Google Colab as well. So as I said, it's a complementary interface. Please notice that. So we're not replacing anything, right? That's not even the aim. So you cannot even do that. So there's amazing APIs already, and the users, you will see that when we compare a little bit and as we go. So some of the features when we talk about cloud-based or local, so you probably have heard a lot about cloud-based computing, So some of the features that the OpenColab we think has versus OpenColab, OpenSim, and on your local computer accessibility, anyone from anywhere can access it, just having an internet. This one doesn't need internet. Local one users, multiple users can work on one piece of code. But here, single PC, for instance, if you're focusing on that, cross-platform, as I said, Mac users, other users, just connected to internet, doesn't matter what you're using. So, but here you would have different types of API, or you need to install different things a little bit. Installation, we made this very simple, like on a Conda, like 6 to 7 minutes. Just run and on the web, and that's it. You have all functionalities. Here we're not talking about the GUIs. We're talking about from scratch building from source code. So that takes like 6 to 7 hours or so. It's quite challenging, right? So of course, as I said, we're not talking about the GUIs and other things. So update or backup, so that in the cloud it's just updating as you go, but here you need to most of the time manually update it. Security, so it is a big Google basis, multiple layer encryption. Basically, your data is secure and constantly updated, but again, make sure where you're putting your data. It's because when we're talking about Google Colab, this is beyond our, reach basically. So that's we are building on other platforms. So that's you have to read about there all the details. Okay. So low security when it is on your computer, but again, people can actually write codes or like get a reverse shell, for instance, capture system. There are possibilities for the security here, the breaches. The fee, as you can imagine, there's no fee here. OpenColab is free, but here, if you have MATLAB or the software packages, you need to pay for it, right? So there's a lot of examples nowadays. People actually, or companies, even big companies, are going toward that. Like Ansys Cloud, you can see FAE Fire Intelligent model, or MATLAB, the cloud base is there, or Abacus. I've been using all these and amazing software packages. So there are great industrial ones. Institute may pay for it, but they're not free, right? And not always open source. Okay. So what is Google Colab? Have we talked about it? Google Colab is the platform here, as you can see, is based on Jupyter Notebook. We have one tutorial that I would love you to have a look before we start this one. So if not, I'll tell you a little bit more about this. So there are demos on YouTube, just great things is from the Google itself and other things, And as I said, I've created something here as well. Google Colab, just have a look at this link. It's about 15 minutes. Went through a little bit of background and how we can write Python codes on the web, and how we can use Google Colab, different scenarios. Okay, so please have a look at that. So OpenColab Interface. So let's a little bit about Colab. If you haven't watched the other one or the other tutorial, so for short, Colab allows you to write and execute Python files, Python codes in your browser. So that's really amazing, right? So you don't need any configuration on your PC. When I say configuration, I mean on your PC. I don't mean like you write a code, there's no configuration for the code, So free access to GPUs, so you can access the TPU, GPU freely. Easy sharing, so we'll show you what we mean. So lots of people can use it, even if you have minimal experience with Python or coding. You can actually start using it. Okay. So that's what we want to build. Our interface, OpenColab, enables users. What we are hoping is that you focus, or we focus on the problem. So far, like even my experience in the last 10, 15 years is there's a lot of setting up, like where the file is, where the, even if you collaborate, there would be a lot of challenges to set up, and you do our simulations, but the main idea is somewhere else. So you just want to sometimes check some ideas. You want to know what's going on with this idea. Does it work or not? So we need zero configuration. That would be amazing. So access biomechanical models, from anywhere, as I said, and free access. We talked about it. Eventually do it faster. Now it's basically another level for the GPU, but it can get better and better as we go, as OpenColab is improving. Easy sharing with colleagues. Again, so we want to use all these possibilities. So simply put it, if it works in one computer, we would love to see it work on any computers across platform. Okay. Some other comparison between you might be interested in, why we have C++, MATLAB, Java, like GUI, why another one, So there are some of the features we brought here. You can have a look on your own time, but quickly, we don't claim this is the best comparison, and definitely it's not. It's a qualitative one. It's somehow the personal choice as well. But some of them are kind of fact, like installation computer. So, when you say two, it's like quite established, not established, or half established. So you can go through them like as 3D visualization. Like OpenColab is not good enough, um, but like MATLAB, it's or GUI, for instance, that you build upon something that is already there on your computer because of the GPUs, so you can do better, right? Or a graphic card cell. Well, I mean, so in terms of open source, post-processing, user friendliness, and so on, a learning curve is something that I always, love to learn things faster. We all love to learn faster. So I believe OpenColab and GUI are quite easy to learn and implement. It's just a matter of a few minutes, so you can just learn and just implement it. Okay. Again, this is not the perfect comparison, but it gives you an idea of where we are heading. Okay. As I said, this is where I would love to see things happening: simplicity. just how simple we can actually set up and start working rather than just dealing with all the, oh, my configuration doesn't work with your configuration, but totally what the problem was. So we're not really solving a problem. You're trying to connect to, if someone sends you a data, you remember the first question I asked, or send you a code, can you run it? That's the key thing. So that's what we're looking for toward 1 minute setup. Less than a minute, just go and set it up. Imagine Collaboratory, as we said, email you, and you have all these, right? You're out of office, no relevant software installed on your computer. Can you run it? So probably not. Yeah, it's not easy. Even if like your professor, your PI don't have probably all these software packages on your computer, but you really want to know, you want to check, right, what the collaborator sent you, right? You sometimes, yeah, you trust, but sometimes you really want to know, what are all these details, right? Just to make sense. So as I said, we have this. I've created a short video here as well. Please watch it in advance. I'll show you right now quickly how it's set it up if you haven't watched this one. So here we go. It's just a few steps. Go to this website, right? Upload the following. We have given you OpenColab on this paper and that IPython notebook, and then wait when it's loaded, then Control F9. That's it. Run it, start running, installs OpenSim and installs all the inverse problem in OpenSim. Okay. So let me, of course, the results will take time. So I would suggest that you do this first and then go back and read the paper to get an idea what's going on, and then come back after 20-30 minutes. It's the whole result. Every single result that we have in the paper can be reproduced here. That's what I would love to see. Um, that's another question that's basically is coming up a lot. That can you reproduce the results? Even if they give you the code, can you really reproduce it? Because you cannot configure the way that they configured it on their computer, you probably can't, right? But this is the way to go, in my opinion. Lots of people are doing it. In fact, it's not, we're not the first one, but you can reproduce it. So we are showing you now that every single graph that you see in this paper can be reproduced, and you can tell us, if it's exactly the same thing. Let me quickly go and you'll see where we are. So if I go to Colab, here we go. So colab.research.google.com, enter, right? When you enter, you will see the, let me just bring the other file. So you imagine you're bringing the file as well, downloading at OpenColab IPython. Okay, so this file, all right. If not, you can actually, if you have it already, it would be here in your examples. But if not, you upload it. So upload it, drag and dropping that one. Okay, and choose the file from your computer. So when I drag and drop it, that's the file that you already have, right? And the success is loaded. You can see it's just, if you start, it's like 10 seconds for now. That's it. So we have all the details, and everything set up for you guys. You can have a look at them step by step. It will take time, of course, but what you can do is you can actually connect it, but it doesn't matter. You can actually go run all. That's it. If it worked on someone else's computer and you do this, it must work here. It would work definitely. We'll come back to this as I'm just explaining other things. So basically, you see here things happening. This is the video that I'm creating, and what is Colaboratory, and what is scripting OpenColab, and some comparison that I showed you, and then the package, that we developed, like installation. So if you want to look at the code, have a look at the code here as well. So you can double click on this, just close the codes, or any part of a code that's happening. So this is the package that's being installed. It's just like 6 minutes, or 7 minutes, and that's it. Every single thing that you need for this notebook to work will be installed here, and that's it. Then the databases will be that, because you need the databases, you need the OpenSim models, and XML files, etc. Everything comes from here. Okay. And then some other functions that we build for plotting, etc. And then a scaling, inverse dynamic. If you just read them, you'll see, for instance, here that you get some idea of like what's the joint, how many joints, how many muscles we have. So we have written a simple code here, which is, I think, based on what OpenSim has written. And then modeling, like all the details that you guys know, the workflow, for instance, and the scaling, and we do the scaling and we do the comparison. So you notice that it's just less than a minute we set it up, and that's it. The rest is just just looking at the data. And if you have any, so imagine someone sends you this data, and then you want to have check some of the codes, and then you go there and say, oh, the result doesn't look good to me, and then you go see what's going on with that, and then you rerun it exactly here, right? So how can you do it with other type of packages on your computer? That's quite challenging, right? Well, that's what I told you about, what 1 minute setup. And here is, now let's talk about what it is. What do we talk about when we say OpenColab? What do we mean, right? As I said, is OpenSim in Google Colab. And the first one, we believe it is in musculoskeletal, like on the cloud, okay? And what we build here is everything is what is out there freely available. And then we put them together from the storage part, from the OpenSim part, from the machine learning part. Everything is there, and then we put them together, and now you can use them. So each part you can actually put your own. For instance, if you want to like say anybody, like another software package, so here IHBM from where I work, like multi system. So you can actually put these things here and then do the rest. Okay. So if you're interested, and if you have access to their API, or if they have the bound binding in what do we call it, Python. But this is what we are going toward. OpenSim is free and in open source, and I would love to see this one. And the GitHub will also just use it as what do we call it, storage here. So you can have your own storage. So we just put the files there, and then we read them, we clone them there, to Google Collaboratory. So we have data. So that's the way the inverse problem works. You have motion data in the lab, right? GRF, like kinematic, kinetic, etc. Whatever data you have, then you can actually import in OpenSim, do all the inverse problem scaling and inverse kinematic, etc. And then we bring it into GitHub, and then at the same time, we bring all the files, like the generic models here as well, into Colab, basically. And here we install OpenSim on the cloud, and then we do the rest. I'll tell you as we go. Okay, so that's the general idea. So let's go step by step. So you collect data. Imagine you collect data. You do it in OpenSim. You can do the procedure wherever you are, any like binding that you have, like GUI, Python, whatever, Then you got some results, right? In the meantime, we have the OpenSim in a Conda, so we have a Conda version of it. So we put the OpenSim data here, the results, as well as the data, the raw data here, right? As well as the OpenSim models, generic models. We put them all in Colab and install OpenSim in Colab. Then we do the visualization and machine learning here. So we compare OpenSim results with the Colab results, so that it would be a validation as well. Okay, makes sense. It's quite simple, but it's very useful. You can use it for a variety of applications. Okay. We have other tutorials for inverse kinematic, dynamic, RA, CMC, because we do all these things in this IPython notebook. So this is the scaling one, and please have a look. It would be just like 7 minutes or so, but we'll have other things. As I said, just enjoy watching them, and then if you want to manipulate them, feel free. So some of the when I shared this with a couple of people, they were asking, oh, what is the point? Or, well, we have all these amazing other things, as I said, APIs. Yep, these are amazing, like on PC or local computers. But I'll give you some case studies. I'm sure that you can find lots of other case studies that I would love to see when this is published. You guys show me that what you can do with this, in terms of collaborations. One example would be this is like a very short learning curve. As I said, like you connect to the VM, the virtual machine, and then you write your code, okay, and then share it with colleagues, and that's it. That is the level of sophistication that I would love to see from a computer programmers. We're talking about computation, we're talking about automation, right? You don't need to do a lot of installations. Everything should be done here. Another example would be dynamic versus static, for instance, presentation, right? You can see that I'm presenting here, but I can actually go and run a code, right? So I can show you where we are in writing that code. So here we are. So you can see the installation is happening. Everything has been installed. OpenSim, the very latest one is maybe a couple of weeks. It's about 1 gigabyte, everything inside OpenSim open source. So we have basically installed it here, right? And let's just go down. It's installing all other packages because we need them too for printing, also for visualization, etc. Okay, I'll show you as we go. Okay, so dynamic versus static presentation. That's quite amazing, right? So you can change things. Let me show you while that's being done. Another way you can have another collab, and not only that, lots of people can have in a let's say we have, for instance, new collab. Okay, and you are in a classroom or your collaborators, right? You can share it, share the same thing with colleagues, right? And they can just have a look at it. And then you're writing a code. Say, oh, A is, you're writing a code, print A. That's it. And then run it, right? And everyone else at the same time can work. It's like a Google Doc, right? It might not be as perfect, but still, people can work on it together, and you can actually have add codes, add text, which this text is also amazing. It's HTML, can get it like latex or LaTeX. You can actually write all sort of things, add movies, add links, etc. Okay, so you see how quick you can do that, right? Alrighty, so let's see if OpenSim is installed. Yep, you see OpenSim installed for 400 seconds, or it's like 6-7 seconds and minutes, and all these files added, cloning. We have all files. If you want, you can have a look at them. Here we go. See all the results, XML files, OpenSim models, etc. All right. And then some useful functions that we already have. Have a look if you like. Yep. Okay. Double click here. OpenSim C3D file. We didn't go through this, but you can do huge things about, this event bringing C3D. This is our next step. So bringing C3D files into OpenSim, etc. So you can see what's going on with that. And the scaling and inverse kinematic, inverse dynamic is happening. So you can see here, we showed some of the features of the model here. And then, like, as I said, inverse problem, just go through them. The inverse problem in GUI, inverse problem in the high scaling engineering in OpenColab. So you can see just less than a second. And then validation. So in terms of validation, you see shows how valid it is. You can compare it. We have in the validation part, you can see that. You keep going and you'll see amazing things like inverse kinematic, how to perform inverse kinematic, plotting them. See, let me just see if they are there. Yep. So all of them are being, and it's dynamic. You can actually have a look at them. You can download them as well, right here. If you look at here, it's dynamic. And what we have done for you is we actually put them all as like it's downloaded itself. So as I said, these are all the results coming for the paper, right? And are here. So imagine you're working with collaborators, and that's it. That's your paper, right? Or a publication, or whatever you want to call it. Okay. So let's go back to this. This is as I said, dynamic versus static presentation. And the case study 3 would be multidisciplinary, as I mentioned, like send comments on the web, visualization on the web, and no configuration, perfectly minimal programming skill. So you notice they don't need a huge programming skill and set up to run simulation. Just keep going and click, keep basically simulation runs. The other one is basically what you do if you're an editor or you're a reviewer. And I would love to see this in the future, that if I'm reviewing a paper, I would love to have such a thing in IPython so that I can run. Then that would be attached as we are showing. We actually share everything with you, so you can actually reproduce everything. So I would love to see the same thing. It's a dynamic review process. When I say dynamic, I mean this one. There are some journals, they call it dynamics. It means they mean that people can see what's going on when they see my name as a reviewer. I don't mean that one. What I mean here is, if you have this graph, I want to reproduce it. Can I reproduce it? And this is the way to go, because if you give me a MATLAB file, that's amazing. Yeah, I probably can do it in, like, if I work on it in 2 weeks. If you give me how to set up things as well, where the files are, there could be it's not like it's not easy to standardize. Of course, if you talk to people from math work, they would say, oh, we have Google Online, like MATLAB Online as well, which is also amazing. But still, yeah, you have to pay for it. It's still slightly different from what we have here. Okay. So I would love to hear from you, and please feel free to use it and take advantage of all the tutorials we've created, all the details, and the file here. Yeah, so it's quite comprehensive. You can see all the details. from inverse dynamic, all the you see the results, the comparison results. And I say here, Colab versus GUI, and the RRA, and the results, as you can see here. And please be mindful of static optimization. Up to here is quite fast. You can see it's not running all the way. It's just maybe 7-10 minutes. But when you go to CMC, as you can imagine, it takes time. And because we are running it for a full, like a 1 gate cycle, 1 or 2 gate cycle, I think, don't remember. So it will take more than 15 minutes. We say here 15 minutes, depends on your computer and connections. So please bear with it. But up to static optimization, it would be very, very fast. So you can even comment this part if you don't want to just go there, but you can leave it like in half an hour or so, plus minus maybe 10 minutes, you'll have it. And then some future work that we are working on it. And yeah, the references. I hope you enjoy OpenColab, which was this idea. And please download it and take advantage of it and give us your comments, and hopefully you can give us more case studies how you're going to use it. Enjoy it. Thank you very much.